Good morning, everybody. First of all, I just wanted to say I miss y'all's faces. I miss seeing you in class. I miss having conversations with you. So I do enjoy when you give me a little feedback like yesterday. And I really appreciate that you all were telling me the types of things that you'd liked last week and the types of things that you didn't really like. Actually, kind of we're all over the place. You enjoyed everything along with the Desmos, the IXL, and sounds like you maybe want a little more. So I'm going to give you a quick little video on IXL I.3. This is going to be an algebra. I know we've been going back and doing 6th grade, 8th grade, and now we're up to the algebra level. We're going to be simplifying expressions involving like terms and the distributive property. You have been combining like terms already, but we're going to step it up enough. Take a look at what does it mean to simplify? Some of you are still having some questions about this. So what we're not going to say here, and this is what I mean by simplify, we don't say there is, let's see, what is this, an apple? Forgot what this was. It's been so long since I've seen one, just kidding. And we don't say apple, we have one apple, one banana, two cherries, one apple, two bananas, and two cherries. That's not simplified. If somebody asked us what we saw, we would combine the things that are alike, right? We would say there are, how many bananas here? There are 3 bananas. We would say there are 2 apples, right? We've got 2 apples here, 1, 2. We've already done the 3 bananas. And then we would say we have, let's do triangles around these guys here. 4 cherries, right? 1, 2, 3, 4 cherries. So that's what it means to simplify. We've got a whole bunch of things and we're just going to combine them into one nice spot here. Slide where we were combining. All right, so let's take a look. Sometimes we collect like terms. And like terms mean that they have the same variable, which are the same letters, with the same exponents. For example, this number 2 here, that's an exponent. So first of all, we have to identify the terms that are alike. It has nothing to do with the signs. It has everything to do with the variables. So let's identify our like terms here. We've got a 5x, and then we've got this other 3x over here. But remember, the sign in front of it goes with it. So these two are like terms. The 2 in the middle are not like the ones on the outsides because they have, these guys in the middle don't have x's. So I have a positive 10 and a positive 7. So just like on the things that are alike, we're going to do the same thing here. So I'm going to take the 5x and then a minus 3. So 5 take away 3 is 2. So I've got 2 x's. And then these 2 in the middle, I've got a positive 10 and a positive 7. That's positive 17. So when I put these together, I put a plus sign in between. This here is as simple as it gets. I can't combine, pretend these are bananas and these are cherries. I can't combine them. They are different because of the variable. So this is our answer. Let's go ahead and take a look at this one. Okay, so now's where it's going to change up a little bit. Sometimes we need to use the distributive property to simplify. We've done this already before. I don't know if you remember the boxes, but we did a box like this, and this guy's going to go on the outside. We were actually multiplying 2 binomials by 2 binomials, but now we've got a single number of 5 times 4m times 9. So I'm going to multiply the numbers. 5 times 4 is 20, and we have 1x. Now I'm going to do the other 2 terms. We've got 5 times 9, that's 45. So I'm going to put this is it, this is my answer. I'm going to put these 2 together, 20x and 45, and I'm going to put a plus sign in between. Not a negative, a plus sign, because it is a positive. Okay, next slide. So this is our example. What I would like for you to do is maybe pause the video for a second so that you can simplify, or try on your own to simplify, and then unpause the video to see the answer. Okay, so what question you should have asked yourself first are which are the like terms. Like terms, remember, have the same variable to the same exponent. So let's take a look here at our first term. Our variable is a q. Do you see another q? I do, but this guy over here has a squared. So that means they are not like terms. So the q is the only one of its kind. The q squared is also the only one of its kind. And then this 2 with no variable, it's called a constant. There is nothing like it. So this is as simple as it gets. It's like saying we have cherries, bananas, and apples, and we can't combine them all together. So our answer here is kind of tricky. It was just 6q plus 8q squared plus 2. We cannot simplify that anymore. Okay, example 2. Go ahead and pause the video again and see if you can identify the like terms and then combine them. Come back for the answer. Okay, so let's first of all identify our like terms. Let's look at our first term here, 3k squared. What I'm looking for are other, you got it, k squareds. So let's see, the second term is a k squared. The third term is a k squared. The last term is a k squared. I'm going to combine all of these together. So what I'm looking for is the number in front. I'm going to take the 3, the negative 2, the positive 4, and a positive 4 here. Now you can get out your calculator if you'd like and combine all of these. So 3 minus 2 is 1. 1 plus 4 is 5. 5 plus 4 is 9. So I have 9. Some of you are forgetting the variables in your answers. We have 9k squareds. 9k squareds. This is our answer. Why did it simplify all the way down to one term? Because they were all like terms. Let's go to the next example. All right, next example, example 3. Go ahead and pause the video again. See if you can simplify this and then come back. Okay, again, so the first question you should be asking is which terms are alike. Let's take a look at the first term. My variables are p cubed q. So I'm looking for that exact same thing, p cubed q. Let's take a look at the second one, p cubed q. This is another one like it, so these two are alike. The third one, p q cubed, not p cubed q. So this one is different. So I'm going to just combine the first two, and I'm just going to take a look at the numbers. 4 plus 2, 4 plus 2 is 6, and those two were p cubed q's. This last term I couldn't combine with anything, so I'm just going to write it over here, plus 3p q cubed. And I know that was a little crazy, but that is the answer there. We have two different things that we cannot combine together. That is our final answer. And the final question. Go ahead and pause the video, see if you can simplify it. Okay, so again, the first question you should have asked yourself is, are these all like terms? Let's take a look what we're seeing here. We have an m cubed. We have an m cubed. And the last term, that's also an m cubed. They are all like terms. So now what's kind of weird here is that we don't have numbers. We've got 2, and then we've got a plus 1, and then a minus, you got it, minus 1. So put this in your calculator, add it however you want. 2 plus 1 is 3, 3 minus 1 is 2. So we end up with 2m cubes. And that's our final answer. They were all like terms. Like terms, again, have the same letters to the same exponents. I'm going to add one more here for the distributive problem. This is our final example. We've got negative 3 times, let's do m plus 5. Okay, go ahead and pause the video and then see if you can set this up. Come back to see the answer. All right, so just like I had done in the example before, we have 2 boxes by 1. So I'm going to put the -3 out here, the m and the 5 here, and then I'm just going to multiply. -3 times 1 is -3, we have an m. -3 times 5 is -15. This is going to be my answer, -3m minus 15. Now, some of you actually like to do the distributive property in a different way, and that's fine. So remember, what the distributive property means is we're going to give this to this number here and this number here. And the answer ends up being the same. -3 times 1m is -3m. And then -3 times +5 is minus 15. So there's our answer in 2 different ways. If y'all have any questions, by all means, please reach out. I will try and make a video for you specifically on a specific question. Please let me know if there's anything y'all need. Again, miss you lots. Have a good day.